Out of the billions of human beings on Earth, fewer than 50 carry the Rh null phenotype. It's a blood type so incredibly scarce that doctors refer to it as golden blood. When found alongside the equally rare Bombay phenotype, it represents a biological profile missing the standard cellular building blocks found in almost every other human being. This 3D molecular model shows what else accompanies those rare blood types. Notice these highlighted segments. These are unusual immune gene clusters, specifically caspase 7 through 12 and TLR3. These genes regulate cellular response and immunity, and possessing these exact mutations is exceptionally rare. These specific markers do not spontaneously mutate in a single generation. They belong to deeply isolated ancestral pockets, and they are passed down directly from mother to child, which brings us to a highly unusual medical anomaly. A modern-day family living in the American South carries this exact ultra-rare genetic sequence. Biologically speaking, these traits are foreign to their immediate environment. To find out how those genes ended up in Texas, we have to treat genetics like a biological time machine. We need to track the direct maternal lineage backward, generation by generation, to locate the geographical source. The modern starting point for this genetic trace is a woman named Martha Jean. Born in the early 1960s, she is a documented carrier of these highly specific biological markers. Stepping backward one generation, we find her mother, Constance Ruth McClellan. Public records show Constance passed away in McGregor, Texas, in the year 2020. She lived to be 89 years old. That lifespan aligns with the longevity advantages associated with the caspase and TLR3 immune genes she carried in her DNA. If we follow Constance's timeline backward, we pull the family's geographic anchor out of rural Texas. She was born in 1931 in Chicago, which was then a primary hub for families arriving from Europe. This graphical recreation of the family's genealogical worksheet reveals Constance's parents, giving us our next historical stepping stone. We have her father, David Alexander McClellan, and her mother, Martha Barbara Carey. Constance was the generational bridge. She was the individual who carried these rare genes through the mid-century migration into the American heartland. To find the source of the genes, we follow Constance's mother, Martha Barbara Carey. Records place her birth around 1907, an ocean away in Scotland. The family followed a complicated transatlantic migration pattern. They originally arrived in Chicago, traveled back to Scotland to settle affairs, and eventually re-entered the United States through Newark. Tracking the maternal line to its final critical anchor point leads us to Martha Barbara's mother. Her name was Mary Carey, and she was born circa 1865 in the Scottish Highlands. But here, the paper trail hit a discrepancy. According to direct oral history passed down through the family, Mary Carey's actual maiden name was Mary Brown. In the Scottish Highlands during the 19th century, name shifting was a recognized tactic. Families used aliases to maintain strict privacy, or in certain cases to obscure a person's parentage and hide a scandal. To find a motive for hiding a child in the 1860s, we look to the highest echelons of Scottish society. Following the death of Prince Albert, Queen Victoria entered a highly guarded, secluded period of mourning at Balmoral Castle. During this isolation, Victoria developed an intensely close relationship with her personal gillie, a Scotsman named John Brown. For over a century, royal historians have investigated a specific rumor from this period: the existence of a secret child. According to these accounts, a daughter was born to Victoria and Brown in 1865 and named Mary Ann Brown. Victoria possessed distinct facial features, particularly her prominent eyes. A child of hers would inherit a specific genetic footprint, potentially combining the Queen's traits with the ruggedness associated with the Brown line. Rumors of a cover-up suggest the Crown may have funded the migration of John Brown's siblings to New Zealand and the United States to ensure their silence. This creates a striking series of parallels. We have a Mary Brown born in the Highlands in 1865, whose family later followed a migration path to the U.S., matching the rumored movements of the Brown family. This lineage sits directly within the footprint of the royal mystery. Accepted medical history already ties Queen Victoria to a famous genetic legacy. She is recorded as the carrier who passed the hemophilia B mutation down through the royal houses of Europe. This theory proposes a second, hidden branch. While the official royal line carried a bleeding disorder to the left, this theorized Scottish branch on the right would have inherited a different genetic legacy, the rare Rh null and Bombay phenotypes. Historical research often reaches a limit at the palace gates, where private records from the 19th century remain sealed or redacted. However, the biological markers found in this Texas family offer a tangible trail pointing back toward the Highlands. If this lineage is indeed the missing piece of the Victoria Brown mystery, it suggests that the most enduring record of the past is carried in our blood.